Assalamualaikum warahmatullahi wabarakatuh. Today, my group and I would like to present to you title DIY Permanent Magnet DC Motor. This is our team. Firstly is me, Syafiqah binti Abdrahim, and my matric number DD240057, and second is Nur Azizah binti Adam, and her number matric is DD240019. Lastly is Nur Amirah binti Muhammad Yaakob. Her number matric is DD240059. Okay, we go to introduction. First, what is a permanent magnet DC motor? A permanent magnet DC PMDC motor is a simple electric motor that turns electrical energy into mechanical motion using permanent magnet and DC power. How it works? When the current flow through the copper wire, it produces magnetic field. This field interact with the magnet field, generating a force that make the wire rotate. Okay, we continue to problem statement. How can students better understand the conversion of electrical energy into mechanical motion in electric motor? Second, how can we design a cost-effective motor model for educational purpose using electromagnetic concept? How can interactive learning tools improve student engagement in understanding electromagnetic concept? Okay, we move to objective project. To demonstrate the working principle of a DC motor using a simple and visible experiment. Second is to demonstrate the conversion of electrical energy into mechanical energy based on the Lorentz force principle. Lastly is to provide a hands-on interactive demonstration that illustrate the role of magnetic field and electric current in motor operation. That's all from me. We move to the next presenter. Thank you.
Okay, I will present about literature review our project, some application of permanent magnet direct current motor, small household appliances, automotive component like windshield wiper and seat adjuster, portable electronic, educational kit and science project such as the demonstration model in this project. So next is role of component in simple permanent magnet direct current motor design. Firstly is copper wire as rotor and conductor. Copper is a good conductor and easy to bend. When shaped into a coil and connected to a battery, it creates a magnetic field. This field react with the magnet field and make the coil spin. We send part of the wire to help the coil spin in the correct direction. Second is neodymium magnet. Very strong permanent magnet creates a strong magnetic field even with a small size. Help the coil spin easily even with a small battery. Second is power supply is battery provided direct current. DC is important to make the magnetic force go in one direction. This steady force keep the motor spinning. Lastly is safety pin. Help the coil spin, connect electricity to the coil, hold part in place, keep the motor balanced. Next is challenges in permanent magnet direct current motor projects. Firstly is contact resistance at the commutation point can cause energy loss. Second is the quality of the magnet influences the torque output and motor speed. Lastly is balancing the armature is critical to achieving smooth and continuous rotation. So next, I will present about methodology our project. So this is list of material we use for doing this project. So we use copper wire, AA 1.5 battery, neodymium magnet, sandpaper, safety pin, digital multimeter, and laser contactless tachometer. So this is a procedure of permanent magnet DC motor project. Step 1, make the coil, take the copper wire and wrap it around a round object like a battery about 10, 30 and 50 times to form a circle coil. Leave 3 cm straight wire on both ends. Make sure the coil is tight and remove it from the battery. Step 2, sand the end. Use sandpaper to remove the insulation from both end of the copper wire, only on one side of each arm. This have electricity flow only one half and make the coil spin. Step 3, make the support bend to safety pin into a shape that can stand and hold the coil horizontally. The safety pin to the top of the battery, one at each end. So next, step 4, add the magnet. Stick the magnet on top of the battery directly under the coil. This will give the coil the magnetic field it needs to spin. Step 5, assembly the motor. Now place the coil end into the safety pin loops. Make sure the coil can spin fairly and is balanced above the magnet. Step 6, take result of current. Connect the multimeter in series with the motor circuit. Turn the dial to DC current mode. Choose a range that can handle around 0 until 1A. Step 7, take result of speed. Stick a small reflective tag or a shiny sticker on the spinning part of the motor like the coil. Aim the laser tachometer at that reflective spot where the motor is spinning. The screen will display the RPM.
And now, I'm going to present for chapter 4, which is result and discussion. As you can see at table 1, we decided to put our number of turn as 10, 30 and 50. And the voltage we use is 1.5 and 3 volts. The current, we use analog multimeter to measure current, and for speed, we use laser tachometer. So next for discussion. Number 1 is effect of number of turn. As the number of turn increase from 10 to 30 to 50, both current and speed increase slightly at the same voltage level. More turns mean a stronger magnetic field is generated, improving torque and efficiency, hence slightly higher speed and current. Number 2 is effect of voltage. A higher voltage, which is 3 volts, so the current increase significantly. Also, speed increase, for example, 850 RPM at 1.5 volts and increase slightly to 1300 RPM at 3 volts. This shows that the voltage directly influences motor power output. Number 3 is current consumption trend. Current increase with both. More coil turns means more higher voltage. And this implies higher electrical power consumption, which we can calculate using power formula, which is P equals to V multiplied I, voltage multiplied by current. So number 4 is speed versus efficiency consideration. While higher voltage and more turns give more speed, they also use more current, which may drain the battery faster. A balance must be found between desired speed and the power efficiency. Lastly is conclusion. The DIY DC motor project successfully demonstrated the basic principle in electromagnetism. Using simple materials like a battery, copper wire, paperclip, safety pins and a magnet, we built a motor that converted electrical energy into mechanical motion. When current flows through the wire placed in a magnetic field, it experiences an electromagnetic force, which is Lorentz force, causing it to spin. This hands-on activity helps us better understand key concepts such as electricity, magnetism, and how motor work in real-life devices like fans and toys. This project was a simple, fun, and effective way to explore physics and engineering. I think that's all from our group presentation. I hope you enjoy with this presentation. Thank you. I think that's all from our group presentation. I hope you enjoy with this presentation. Thank you.